A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away. Maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents, the crew finds, after 4 hours, that the sailboat is off course by 20 degrees. How far is the sailboat from Key West at this time? Through what angle should the sailboat turn to correct its course? And how much time has been added to the trip because of this? And we'll assume the speed remains 15 miles per hour. We're given that the distance from Naples to Key West is 150 miles. We know that the ship is off course by 20 degrees, so the angle between the path it should have taken and the actual path is 20 degrees. We're given that the boat was traveling for 4 hours at 15 miles per hour, so the boat traveled 60 miles before they recognized they were off course. So we have a triangle here. I'm going to recreate the triangle on paper over here so that we can get a better understanding of what's going on. Currently the boat is located at this point. We want to know how far the boat is from Key West. In other words, we want to know the length of this segment of the triangle X. If you look carefully, you should see that we have a side, angle, side triangle, which means that I can use the law of cosines to find x. In fact, x squared is going to equal 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of the angle 20 degrees. If we work this all out, we would get that x squared is approximately equal to 9186, and that's square miles technically. So if I square root both sides, I get that x is about equal to 95.8 miles. So to answer part A, the boat is about 96 miles from Key West. What we want to do next is determine the angle theta for which the boat should turn. In other words, the boat's headed in this direction currently. It needs to turn so that it can head in this direction. The way we're going to work this out is we're going to use the law of cosines again to find this angle alpha. Then we'll use the fact that these are going, alpha and theta are supplementary angles, to find theta. In other words, we'll find theta by taking 180 degrees minus alpha. So, how are we going to find alpha? Well, we now know that the value opposite alpha is 150. We know that the value of x is about 96. And so, we have the fact that we know the opposite side. We know these two sides, right? And so we can use the law of cosines again. Here's how we're going to do it. We have that 150 squared is going to equal x squared. Is going to equal x squared plus 60 squared minus 2 times x times 60 times the cosine of alpha. In other words, I'm solving for alpha based on a side-side-side triangle. If we solve for the cosine of alpha, we're going to get eventually that 9684 equals negative 11,520 times the cosine of alpha, so that the cosine of alpha is equal to negative 0.8406, dividing both sides by negative 11,520. That means that alpha is about 147.2 degrees. Now that we know alpha is about 147.2 degrees, we find the angle theta by taking 180 degrees minus that 147.2 degrees, again because alpha and theta are supplementary to each other. So we get that theta is equal to about 32.8 degrees. Therefore, the sailboat should turn to an angle of about 33 degrees to head back on course towards Key West. Finally, what we want to do is determine how much time has been added to the trip. Well, we can do that by figuring out the total distance that the boat is going to travel. It's going to travel 60 miles when it initially went off course. Then we have that x is 96 miles. So the boat's traveled 156 miles. Compare that to the 150 that it was supposed to travel. So we really only added 6 miles to the trip. So because of the fact that we've added 6 miles and we're traveling at 15 miles per hour, 6 divided by 15 is equal to 0.4 hours. 0.4 hours times 60 minutes per hour is 24 minutes. So the fact that they were off course only added about 24 minutes to the trip.